In the previous lecture, we have gone through the characteristics of the Zener diode and how a regulator circuit looks like, and some basic level problems we have gone through. Now, let us have a look at the various cases in the design of a voltage regulator circuit using Zener diode. The first case is the range of input. I mentioned there is a range of input such that even for the minimum value of input, the current through the Zener diode should not fall below its neck current. I told that. And even for the maximum value of the input voltage, the current through the Zener diode should not exceed IZM. If it exceeds the maximum allowable current through the Zener diode, then the power dissipation across the Zener diode PZ is equal to VZ into IZM, that exceeds the power rating of the Zener diode, or the minimum power rating I can say, so that the Zener diode will burn. So we should not entertain the current through the Zener diode to exceed IZM. So which means there is a limit on the range of your input. How do we find the values of V input minimum and V input maximum? Let us see that. So we know that if I take this equation as I, this current through the series resistance as I, current through the Zener diode as IZ, and it is VZ with polarities plus minus, current through the load resistor RL, and V output, it is equal to VZ. We know. So here I kept RL constant. So we know that V output is equal to VZ is equal to IL into RL, implies IL is equal to VZ by RL. Here VZ is constant, RL is constant, and hence IL is constant. Next, I can write I is equal to V input minus VZ by R. Here the voltage is V input, here the voltage is VZ. Okay, this is anyway ground, by R, that gives us the current I. Okay, and also if I take the node equation at this particular point, I is equal to IZ plus IL, where IL is constant. Okay, suppose input is increasing, then definitely I will increase, because VZ and R are constants. If I increases, then IZ will definitely increase, because IL is constant again. Is it not so? Means IZ is proportional to V input, no doubt about it. Or if V input decreases, definitely I will decrease. If I decreases, IZ will also decrease. Very, very simple thing. Means IZ is proportional to V input. That's what I told even in previous lecture. Okay, IZ is proportional to input. So what I can say, I can reduce the input such that even for the minimum value of input, current through the Zener diode should not fall below its neck current. That's it. So even for V minimum value of V input, current through Zener diode IZ should not fall below its neck current. Very simple statement. Okay, means as input is minimum, the corresponding I is also minimum, and corresponding IZ is also minimum. So what I can write from this means, I can write here I minimum is equal to that IZ minimum, that is neck current plus IL. As I is minimum, the corresponding value of input is also minimum. So what is VI? VI is equal to, if I take this loop equation, VI is equal to I into R plus VZ. So we know here V input is equal to I into R plus VZ. Or I is minimum means the corresponding value of input is minimum. V minimum is equal to I minimum into R plus VZ. That's it. This is the minimum value of input. Okay. How you are defining it? It is from this basic equation. Iz is proportional to input. Similarly, what we can take, even for input maximum, current through the Zener diode should not exceed its IZM. Okay, so take that as my second step. So even for V input is equal to V max, Iz should not exceed IZM. Okay, which means the as input is maximum, the corresponding current from the source is also maximum. I can write I max is equal to IZM plus IL. So implies V max is equal to, we know V input is equal to I into R plus VZ. Instead of V, I am writing V input, I am writing V max. Instead of I can write I max into R plus IL. That's it. This is the maximum value of input. Okay, very, very simple statement. And of course, in the problems, if they give the specification, generally what they do, they give the specifications like Iz minimum, Iz maximum, Vz, RL, etc. So that based on that, right, some questions they will be asking. If they do not give Iz minimum, then we can assume Iz minimum or the knee current of Zener diode to be 0. If Iz minimum is given, well and good. If it is not given, we take Iz minimum is equal to 0. Please do observe that. So based on this, let us do some problems. You see how simple they are asking the questions in the GATE exam. See this. GATE 2019, it's a recent paper only, not very old. In the circuit shown, the breakdown voltage and maximum current through the Zener diode are 20 volts and 60 milliamperes respectively. Okay, so in this problem, Vz is given as 20 volts and Izm is given as 60 milliamperes, Vz and Izm. The values of R1 and RL, okay, R1 means the series resistance, it is 200 ohms and RL is equal to 1 kilo ohm. Okay, what is the range of Vi? You see, what is the range of Vi that will maintain the Zener diode in the breakdown state? What is the range of V input they are asking? Okay, here Iz maximum is given, Iz minimum is not given. Then what do we do? Assume Iz minimum is equal to 0. So the key point here is assume Iz minimum or the knee current of Zener diode is equal to 0. Done. Then let us have a look at the calculations. This is I, Iz, IL. Okay. So first let us calculate IL, that is Vz by RL. Its value is Vz, it is 20 volts, 20 by 1 kilo ohm, that is 20 milliampere. Okay. Then what about I? I is equal to Iz plus IL. We know that. Okay. And I minimum is equal to Iz minimum plus IL. It is 0 plus 1, 20 milliamperes. No? It is 20 milliamperes. So V minimum is equal to I minimum into R plus Vz. It is 20 milli into R is 200 plus 20. It is equal to 24 volts. Then I max is equal to IZM plus IL. IZM is given as some 60 milli, yes, 60 milliampere. Plus 20 milliampere, it is 80 milliampere. So V max is equal to I max into R plus Vz. I max is 80 milliampere into R is 200 plus Vz is 20. It is 36 volts. Very, very simple question. You can vary the input from, okay, not the second question, first one. Okay, 24 to 36 volts. Option B is correct. Okay, when input is 24 volts, the corresponding Iz is 0 and the corresponding IL, I is equal to IL is equal to 20 milliamperes. We can take, then when input is going up to a maximum of 36 volts, that time I is equal to, okay, 80 milliampere, I think so, because Iz is equal to 60 milliampere and IL remains constant at 20 milliampere. That's it. So we can vary the input from 24 to 36 volts so that the current through the Zener diode will change while maintaining a constant voltage of 20 volts across RL. That's the thing here. Very, very simple point. Take the next question. A Zener diode in circuit shown in figure has a knee current of 200 milliamperes and maximum current of 2 amperes. Okay, Vz is equal to 18 volts and RL is equal to 18 ohms. Find R1. What is R1? If V input is varying between 22 to 28 volts. Okay, fine. Iz range is given, Vz is given. Okay, so as usual, what I am doing is, first I am calculating IL. IL is equal to Vz by RL. So 18 by 18, it is 1 ampere. Right. So how to write R1? So we can take I. I is equal to Iz plus IL and R1 is equal to V input minus Vz by I, general equation. And I can write the R in terms of V minimum or V maximum. Okay, so I can write here R is equal to input is minimum, means the corresponding I should be minimum, no doubt about it, and I minimum is equal to Iz minimum or the knee current plus IL. We can use this. So what is V minimum in this example, friends? 22 minus Vz is 18 and the knee current is 200 milliamperes, means 0.2 and IL is equal to 1. So it is a 4 by 1.2. It gives us 3.33 ohms. Okay. Why don't we try the same thing with V maximum? Yes, it is possible. R1 can also be written like V max minus Vz by I max. And V max minus Vz by I max is equal to Izm plus IL. So V max is 28 minus Iz 18 by 2 plus 1. 10 by 3. It is also 3.33 ohms. Absolutely you are getting. See, you can use either V minimum or V maximum. V minimum means current through the Zener diode should be minimum. And input is maximum, means current through the Zener diode should be maximum. Anything you can use. You should get the same answer. If you do not get, the data given might be wrong. Okay, see, here I wrote the statement like V minimum is equal to I minimum into R plus Vz. Means R is equal to V minimum minus Vz by I minimum. Absolutely. And second one, V max is equal to I max into R plus. Oh, sorry friends. It is not IL. Sorry, it is Vz. Okay, thank God I have come back. So R is equal to V max minus Vz by I maximum. That's it. Okay. This is the idea. Very, very simple question. Okay, just like that you can score marks here. No difficulty in this at all. Next, see this question, 2018 electronics paper. The circuit shown in figure is used to provide a regulated voltage of 5 volts across 1 kilo ohm resistor. Okay. Assume that the Zener diode has a constant reverse breakdown voltage for a current range starting from a minimum required Zener current IZ minimum of 2 milliamperes to its maximum allowable current. IZ maximum is not given. Okay, the input voltage V may vary by 5% of its normal value of 6 volts. The resistance of the diode in the breakdown region is negligible, means RZ is neglected. The value of R and minimum required power dissipation rating of the diode respectively are. Okay, they are asking the value of R and the power rating of the Zener diode. Okay, very good. And IZ maximum is not given. In that, and IZ minimum is given, means we have to start with V input minimum. Is it not so? So first let us take this current as I. It is Vz. This current is Iz and it is IL. So what is IL? I am just writing the same circuit with input minimum. What is input minimum? Here 5 by varying by plus or minus 5% of its nominal value. So V minimum is equal to from 6 volts minus 6 into 5 by 100. So it is 5.7 volts. What is R? We need to find. And this current is minimum, I minimum. Then the current through the Zener diode should be knee current. It is 2 milliampere. RL is equal to 1 kilo ohm. So IL is equal to VZ by RL. Its value is 5 by 1K. 5 milliamperes. V minimum is known, IL is known, and knee current is also known. So I minimum we can write. R, I can write R is equal to V minimum minus Vz by I minimum. What is V minimum here? Okay, and V minimum minus Vz by I minimum, it is I knee current plus IL. So how much do we get here? V minimum is 5.7 minus Vz 5. So R is equal to 5.7 minus 5 by 2 plus 5, 7 milliampere. 0.7 by, so it is equal to 100 ohms. R value. So 100 ohms means you can see two options here. Okay, let it be. The next point, minimum power rating. Minimum power rating of the Zener diode is defined in terms of IZM. Okay, IZM. So current through the Zener diode is maximum if and only if the input is maximum. Okay, so let us take the circuit again. V maximum. What is V maximum, friends? 10%, right? 5% of its nominal value. 6 plus 6 into 5 by 100. Anyway, 0.3 it is. 6.3 volts. R is found to be 100 and this current is maximum. That time current through the Zener diode is maximum. RL is equal to 1K and IL is equal to 5 milliamperes. Okay, so what about I maximum? I max is equal to V max minus Vz by R. 6.3 minus 5 by 100, it is 13 milliampere. Okay, so what about IZM then? I max minus IL. It is 13 minus 5, okay, 8 milliampere. IZM we have got. Then PZ rated, minimum power rating. See, don't think like minimum power rating means IZ into IZ minimum into VZ. That is absolutely wrong. Minimum power rating is a specification. Maximum allowed power dissipation or maximum power dissipation in the Zener diode should be less than its rated power or minimum power rating of the Zener diode. That's very, very important. Right? People will have a confusion. Minimum power rating means they will think like what is the minimum power dissipation in the Zener diode? Absolutely wrong. They are not asking minimum power dissipation in the Zener diode. The maximum power dissipation, which is known as minimum power rating of the Zener diode. So PZ rated, it is equal to VZ into IZM. VZ is equal to 5 into 8 into 10 power minus 3. It is 40 milliwatts. Look at the options. So option B is correct. It's a simple question. Okay. So this is how we can see some problems on the range of input. The next case is range of RL. Here what I am doing is first for better understanding I started with no variables, right? We input R, RL, Zener diode, etc. Next I started with keeping RL constant and V input is variable. Now I am keeping input constant and vary RL. So that what about the range of RL? Next case what I do, I vary both input and RL and how the circuit is maintaining constant voltage across RL. We'll see that. Next we vary this R also. These are all various cases they are asking, nothing else. It's very, very simple circuit and the calculations are also dead easy. Okay. Then let me call this current as I. This is VZ, IZ, IL, and V output is equal to V. See this. First I can write I is equal to V in minus VZ by R. Here V in is constant, VZ is constant, R is constant, and hence I is constant. In the previous case, as RL was constant, IL was constant. Here, as input is constant, I is constant. Okay, fine. And what about this IL? IL is equal to VZ by RL. Okay, so if RL increases, IL will decrease to maintain the output constant at VZ. Is it not so? If RL decreases, IL has to increase. There is an inverse relation because we know V output is equal to VZ is equal to IL into RL. RL increases, IL has to decrease and vice versa. Okay, fine. And also we know that I is equal to IZ plus IL, in which this I is constant. Then if RL increases, IL will decrease. If IL decreases, IZ has to increase to see that I is constant, which means IZ is proportional to RL. Please observe this. Earlier case, IZ was proportional to V input. Here, IZ is proportional to RL. Okay. Similarly, if RL decreases, IL has to increase. If IL increases, IZ has to decrease to maintain I constant. So what we can understand here is IZ is proportional to RL. Very, very interesting point. If I reduce RL to maintain constant output voltage, what happens here? If RL decreases, IL has to increase to see that output is constant. If IL increases, automatically IZ has to decrease. So RL is minimum means IZ is minimum. You can reduce RL such that current through the Zener diode should not fall below its knee current. Okay. Similarly, if you increase RL, IL will decrease, means IZ will increase, so that even for maximum value of RL, IZ should not exceed IZM. That's how we can find the range of RL based on these points. So what I can write here is, first anyway I is constant, so let me write for RL is equal to RL minimum, IL is equal to IL maximum, for which IZ should be equal to its knee current, IZ minimum, okay, which is known as knee current. So from this what I can write is, anyway RL minimum is equal to VZ by IL maximum. What is IL? From this even I can write IL is equal to I minus IZ. So VZ by I minus IZ, and VZ is anyway constant. Here IL is maximum when IZ is minimum, or knee current, anything we can write. RL minimum comes from IZ minimum. Okay, this is how we can write RL minimum. Similarly, RL maximum, how to take RL maximum. Okay, if IZ minimum is not given in the problem, then what we can take? IZ minimum is equal to 0, right? It is possible. That depends upon the specifications they give. Okay, next, for RL is equal to RL maximum, definitely IL is equal to IL minimum, which implies the corresponding current through the Zener diode is maximum. Okay, so RL maximum is equal to VZ by IL minimum, that is VZ by I minus IZM. That's it. This is the idea. Okay. Sometimes there is a scope of a RL maximum to be infinite. It is possible. See, actually I started with the regulator circuit this way. This is where I started actually. This is input R and the Zener diode. An entire current was going through the Zener diode. The current coming from the source is flowing through the Zener diode. Later we connected the load resistor. If you connect RL, then accordingly the things are taking place. And RL can take a maximum of infinity. If RL is equal to infinity, means 1 by 0, I is equal to IZM. RL is infinity means IL will be 0. In that case, I is equal to IZM. It is possible. Okay. RL maximum, it can take up to infinity. Possible. If RL maximum is infinity, then IL minimum will be 0 and I is equal to IZM. IZM never exceeds I. See the questions based on what we have seen. A 6 volts Zener diode shown in figure has 0 Zener resistance, means RZ is 0, and a knee current of 5 milliamperes. Okay, the minimum value of R means the load resistor, they are naming it as R. Let it be. We have followed some notation like series resistance is equal to R and load resistor is equal to RL. Let it be. They need not follow the same notation. Okay, minimum value of R, so that the voltage across it does not fall below 6 volts. So what is R minimum, they are asking. Okay. Right. R minimum means that comes from IZ minimum. So what is I here, friends? I is equal to V input minus VZ by R series resistance. It is 50 ohms. So 4 by 50. Generally what I do is converting it to milli, means 20 by 20. If I take so, it becomes 80 milliamperes. Okay. I we have got. And here R should be equal to R minimum. R minimum means current through the Zener diode should be knee current only. Okay, and the current through the load resistor, it is maximum. Is it not so? So R minimum is equal to VZ by IL maximum. which is Vz by I minus the knee current. Vz is 6 and I is equal to 80 milliampere minus the knee current, it is 5 milliampere. So 6 by 75 into 1000. So 3 2s, 3 25s, 25 40s, it is equal to 80 ohms. Option C is correct. Very simple question. Next, the circuit shown in figure has a Zener regulated power supply. Okay. Assuming that the Zener diode is ideal, minimum value of RL, again they are asking RL minimum, due to which the output voltage remains constant will be. They are asking RL minimum, means IL maximum. And current through the Zener diode should be knee current. It is minimum, IZ minimum. No? This current I is anyway constant. They have not mentioned anything about IZ minimum, and hence what you can take, assume the knee current is equal to 0. Very simple thing. And what about I? I and IL will be automatical, IL maximum will be same. So what about I here? It is V in minus Vz by R, that is 25 minus 15 by, 24 minus 15 by 27. Okay, 9 by 27, it is 1 by 3 ampere, 0.33 amperes. Okay, I value we have got. Then RL minimum is equal to Vz by I max. It is Vz by I minus the knee current. Vz is equal to 15 by 1 by 3 minus 0. It is 45 ohms. Option B is correct. You don't require much thinking also. See, gate problems means sometimes for solving few questions, we have to break our head like anything. But if you know the concepts of analog, they are very simple actually. There should be a proper approach. Once you understand that, just like that, you will solve the questions without any confusion. You will see that. Earlier, see, you can solve the questions on regulator so far before my lecture and solve them after my lecture. You feel like while reading the question itself, you can generate the answer without much difficulty. You need not think much. Not only the first question or two question, even the last question I will solve in a similar manner. You will see that difference. Next question. A Zener diode in circuit shown in figure has knee current of 5 milliamperes and maximum allowable power dissipation of 300 milliwatts. So maximum allowable power dissipation there means minimum power rating of the diode. Okay, from this indirectly they have given IZM, right? Knee current and IZM both are given. What are the minimum and maximum load currents that can be drawn safely from the circuit, keeping the output voltage constant at 6 volts? Instead of asking RL minimum and RL maximum, they are asking IL minimum and IL maximum. Nothing to worry about it. So see, this current is I, IZ, IL. So first we need to calculate I is equal to V in minus Vz by R. So it is a 3 by 50. It is 60 milliampere. Simply I can multiply and divide with 20 so that it is a 60 milliampere. I we have got. Then IL minimum I want. IL minimum is equal to I minus IZM. When current through the Zener diode is maximum, the corresponding IL is minimum. So it is a 60 milliampere minus IZM. Oh, IZM means I should know the power rating. First, let us calculate IZM. Sorry, IL maximum. It is I minus the knee current. It is 60 milliampere minus the knee current. How much? 5. It is 55 milliampere. So the interesting point here is 55 milliamperes is here. So I need not worry about finding IL minimum because nowhere we have that 55. No. So here itself we got the answer. In the exam you can stop here. Nothing to worry. Okay. Whereas for our self-satisfaction sake, we have to continue the things. Like anyway, IZM, I need to find. IZM is equal to PZ rated by VZ. It is equal to 300 milliwatts by 6 volts. It is 5 milliamperes. IZM we have got. Once you get IZM, then I can write IL max is equal to I minus IZM. It is 60 minus, sorry, IL minimum, no? IL minimum. I minus IZM $50. 300 milliwatts, so it is 50 milliampere. Sorry. So 60 minus 50, it is 10 milliampere. Okay. Mathematical calculation mistake. Okay, fine. So that's it. Okay, it is a 300. I wrote 30. That's why the 50 milliampere. So this is the answer. Okay. It's a simple one. Next. In the voltage regulator shown in figure, the load current can vary from 100 milliampere to 500 milliampere. Means RL is varying with right IL minimum and IL maximum. Assuming that the Zener diode is ideal, that is the Zener knee current is negligibly small, that is IZ minimum is 0 and Zener resistance RZ is also 0 in the breakdown region. What is the value of R? Okay. So here this current is I, this is IZ and this is I. We know that I is equal to IZ plus IL, which can be written like IZM plus IL minimum, or it is the knee current plus IL maximum. Which equation can we use to find I? Once I know I, then R is equal to V in minus VZ by R. Sorry, VZ by I. We can take it. So here what we can do, minimum, right, the knee current is negligibly small, means what we do, assume the knee current is equal to 0. So it is a 0 plus IL maximum, it is 500 milliampere. That is 0.5 amperes or 1 by 2 amperes. Then what is R? R is equal to V in minus VZ by I. I is equal to 1 by 2. So it is 14 ohms. How simple the question is. Look here. Okay. The Zener diode in the below figure regulates at 50 volts range, 50 volts or a range of diode current from 5 to 40 milliampere. Okay, Zener diode specification circle. Supply voltage is 200 volts. Calculate the value of the resistance R to allow a voltage regulation of the range of load current IL is equal to 0 to IL maximum, and calculate the maximum load current IL maximum they are asking. IL is 0, they are mentioning. IL is 0 means what is RL? IL is minimum value of IL minimum is 0 means what about RL maximum? It is infinity. Yes, right. That is possible. RL maximum is infinity in this problem. Let it be. Okay, they're asking us to find IL maximum. IL is maximum means RL should be minimum. RL is minimum, then only IL is maximum. And RL is minimum means IZ should be equal to its knee current. And this is I. Okay. So calculate the resistance R and IL maximum they are asking. Okay. First point. For calculating I, we should know I. For calculating R, we should know I. How to write I? I can write I is equal to IZ plus IL, and IZ minimum is known, but IL maximum we do not know. They are asking us to find. So the second equation is IZ maximum plus IL minimum. This equation we can use, because other equation, if I take it, so I plus IL maximum, but I is known, knee current is known, but IL maximum is not known. So I am using only this equation. IZM, it is 40 milliampere plus IL minimum is 0. Okay, so we got the value of I. If that is the case, R is equal to V in minus VZ 50 by I. The students may be having confusion, and as we are in the learning stage, I can write few more steps, not an issue. 200 minus 50 by 40 milliampere. So it is 15 by 4. 15 by 4 means 3.75 kilo. 3.75, yes. R we have got. Once we get R, okay, then I'm just erasing this case, these things. Okay. Just I'm writing this. Okay. So for maximum load current, IZ should be maximum. We can find IZ maximum is known, I is known. Then, okay, sorry. So from I and IZ maximum, I can find IL minimum. Okay, that is known already. What they are asking us to find IL maximum. Okay, simple thing. Here, I'm taking this one, RL minimum. You cannot take RL minimum 0. Here it is IL maximum. As RL is minimum, IZ is minimum. And what about this R? It is 3.75K. Input is 200, no? And the current I is equal to 40 milliampere. So IL maximum is equal to I minus the knee current. It is 40 milliampere minus, I think knee current is 5 milli. Yes, 5 milli. $35 milliampere. So what is the correct option? 3.75 and 35 milliampere. Option B. See here 3.75 kilo ohms we have in two options B and D, but in option B only we can see this 35 milliampere. So you cannot simply stick with one calculation. Here previous problem it was given, so that we need not worry about the second calculation, but here we should be okay. It happens. Okay. Next question. In the following circuit, the 5 volts Zener diode requires a minimum current of IZ minimum is given 10 milliampere. For obtaining regulated output of 5 volts, the maximum permissible load current IL is IL maximum they are asking, and minimum power rating of the Zener diode. Okay. What is there in it? It's a simple question. So what is IS? The current through the series resistance. It is equal to V in minus Vz by R. It is 10 minus 5 by 100. It is 50 milliampere. I we have got. Okay. Then minimum GNR current is given. IZ minimum is given. So the maximum permissible load current IL is maximum. So we are well aware here in this. I am rewriting it without calculations also we can write. When RL is minimum, then IL is maximum. And that time IZ is minimum. I is anyway constant. Input is 10 volts. And that value IRIS, it is 50 milliamperes. That's the meaning of it. Then IL maximum is equal to IS minus the knee current. It is 50 minus the knee current is 10 milliampere. So it is 40 milliampere. So maximum permissible load current is 40 milliamperes, just like that we got. Next, minimum power rating of the generator. Okay. Means IZ maximum should be found. For getting IZ maximum, right, is it given in the data? No. Then how to take it? They have not mentioned about RL maximum. So what do? Assume RL maximum is infinite. Assume RL maximum is infinity. If that is the case, IL minimum is equal to 0. Obviously, if that is the case, I need not draw the circuit. Sorry, 10 volts. No? 10 volts, 100 ohms. It is 40 milliampere, and it is infinite. Sorry, current is 0, resistor is infinite, and IL is 0. IL minimum is 0. RL is maximum, means that time current through the Zener diode is IZM. So what is IZM, friends? It is equal to I is equal to 40 milliampere. Then PZ rated, it is equal to VZ into IZM. It is 5 into 40. It is 200 milliwatts. Okay. So, okay, IS is 50, sorry. IS is not 40, it is 50, and hence it is 50. It should be 250. If they ask in watts means 0.25, 0.25 watts. Okay. This is how we can do it. Minimum power rating is possible with IZM. IZM comes with RL maximum, and we are assuming RL maximum is equal to infinite. That's it. Next, see this question. 2013. For the circuit shown below, the knee current of the ideal Zener diode is 10 milliamperes. Same problem only to maintain 5 volts because 10 volts, 5 volts, 100 ohms, same problem. Right? The minimum value of the load current RL and minimum power rating of the Zener diode respectively. Right? What is there in it? It's a simple question. Okay. Okay. Instead of asking IL maximum, previous problem they asked IL maximum, they are asking RL minimum. Nothing else. So first, let us calculate I. I is equal to V in minus Vz by R. How much do you get? It is 50 milliampere. Same problem, no? Nothing special about it. IZ minimum is also same. Knee current is also same. Okay. So then I can write RL is minimum, but the minimum value of load resistor Vz by IL maximum, that is Vz by I minus I knee current. Vz is 5 by 50 milliampere minus 10 milliampere. 5 by 40 no? Into 1000 for 25, 125 ohms. R value, okay, two options have 125, so we need to solve for second part as well. Okay, it is fine. Minimum power rating of the generator. For that I should know IZM. IZM is possible with RL maximum. Assume RL maximum is equal to infinite. Implies IL minimum is 0. If that is the case, IZM is equal to I minus IL minimum, that is I is 50 milliampere and IL minimum is 0. So PZ rated Vz into IZM, it is 5 into 50 milli. Minimum power rating of the Zener diode, it is 250 milli. Previously also the same answer, no? Okay, 250 milli. Same circuit. Earlier they asked IL maximum, they are asking now RL minimum, nothing else. Very, very simple question. Next one. Okay, if input and RL are varying simultaneously, how the circuit is maintaining constant voltage of Vz? That's our concern. Next part. Various cases, right? We started with very, very simple things and extending. Okay. So, from the two previous models, what we can understand, IZ, current through the Zener diode, is proportional to input and it is proportional to R. If V input decreases, IZ will decrease, and if V input increases, IZ will increase. Similarly, IZ is proportional to RL, right? RL decreases, definitely IZ will decrease, and if RL increases, IZ will increase. So we understand that IZ is proportional to V input and IZ is proportional to RL. No doubt about it. Okay. It's very, very important point. That's what we understood from the previous two things. Okay, done. Then, okay, for proper working of it, for minimum value of input and for minimum value of RL, current through the Zener diode should be minimum. Simple. And input maximum and for RL maximum, current through the Zener diode should be maximum. That's it. Very simple statement. If V input is minimum and RL is equal to RL minimum, that time IZ should be equal to its knee current. Please observe this. Okay. So what we can write here is V input is minimum, or as input is minimum, I should be minimum, and here as RL is minimum, IL should be maximum. As input is minimum and RL is minimum, IZ is minimum. That's it. This is how the circuit is. This combination only should be used. You cannot take V maximum, RL minimum, etc., etc., and IZM and all. Okay. As we understood, IZ is proportional to input and RL. When both are minimum, that time IZ should be minimum. Okay. Now we can develop the equations like I minimum is equal to V minimum minus Vz by R, and IL maximum is equal to Vz by RL minimum. and also I minimum is equal to the knee current IZ minimum plus IL maximum. It is not possible to write I minimum is equal to I knee plus IL minimum. Current through the Zener diode and load current cannot be minimum simultaneously. Impossible. Okay. IZ is proportional to RL. RL is minimum means IL should be maximum. Okay. People think like I minimum is equal to IK plus IL minimum, which is a big blunder. You can't take so. Next, both are maximum. Means if input is, if Vin is equal to Vmax and RL is equal to RL maximum, the corresponding IZ should be equal to IZM. No doubt about it. Here it is IZ. So take the circuit. Input is maximum, R and RL is maximum. As input is maximum, I can take this current as I maximum. Current through the Zener diode is IZM and it is IL minimum. That's it. So I max is equal to Vmax minus Vz by R, and IL minimum is equal to Vz by RL maximum, and also I max is equal to IZM plus IL. This is interesting. Okay. Next point. Right. If IZ minimum is not given, what we can take? IZ minimum is equal to 0. If RL maximum is not given, we can assume RL maximum is equal to infinite. Again and again I am telling, to see that students should not forget these points. Okay. Now, based on this, let us have a look at some problems asked in previous papers. It's a question asked in previous GATE papers. I forgot to write the year in which it is asked. Okay. See this question. In the voltage regulator shown in figure, the load current can vary from 10 to 85 milliampere. The Zener knee current is 15 milliamperes and the breakdown voltage is 10 volts. Okay. Find the value of R and minimum power rating of Zener diode if V input varies between 13 to 16 volts. Okay. The range of input is given and okay, minimum value, right? And they are asking us to find. Anyway, load current is varying from 10 to 85 milliampere. Means RL is also varying. Both are varying. Okay, done. So what do we do? They are asking us to find the power rating of the, means IZM is should be calculated. IZM is not known. What current data we can use? When input is minimum, RL is minimum, that time IZ is minimum. IZ minimum is also known to us. Let us use that value. IZ minimum. Okay, what we can take? IZ minimum is okay, it is 15 milliamperes. So let me take that part. V input is minimum, R RL is minimum, IL maximum. The load current is varying from 0 to 85, sorry, 10 to 85 milliampere. So IL maximum is this, and the knee current is given by 15 milliamperes. That time the current here is I minimum. V minimum is equal to 13 volts. So what about V minimum, friends? Okay, V minimum is known. They're asking us to find R no. Okay, I minimum is equal to the knee current plus IL maximum. It is 15 plus 85, 100 milliampere. Once you get I minimum, that time R is equal to V minimum minus Vz by I minimum. It is 13 minus 10 by 100 milli, means or 0.1. It is 30 ohms. R value we have got. Okay. Once we get R, then okay, redraw the circuit with V input maximum. (16 volts), R is equal to 30 ohms. As input is maximum, RL is also maximum. So that IL is minimum. Its value is given as, I think, 10 milliampere. And here this is IZM. As input is maximum, I is maximum. So I can write I max is equal to V max minus Vz by R. It is 16 minus 10 by 30, 6 by 30. Okay, 6 by 30 means 1 by 5, no? 1 by 5 means 0.2 ampere or 200 amperes. 0.2 ampere or 200 amperes. Okay, then what about IZM? It is I max minus IL minimum, that is 190 milliamperes. So PZ rated, it is equal to Vz into IZM. Vz is 10 volts into 190 milli, 1.9 watts. Okay, minimum power rating of the Zener diode. Is it not so? Okay. IL minimum is 10. Okay. So this is the idea. Okay. Now we can analyze this. From this circuit only, I will just explain the analysis once again. Okay. What is happening here? Just directly I am writing 200 milli here. Actually place is not there. I want to explain something here. See this, in this problem, let me change the colors. Input is minimum, that time RL is also minimum. We need not worry about the value of RL minimum value. If you want, you can calculate it. How much it is? 10 by 85, 1000 by 85, it is RL minimum. If you take it, it is because Vz is 10 and IL is 85. Okay, so 10,000 by 85 I can write. 85 milli, no, 10 volts by 85 milli, we can get some value, RL minimum. Okay, with V input and RL minimum, we can see the minimum current is 100 milliampere. We have seen, okay, and the Zener current is like this. Later, I am increasing the input voltage to some 16 volts. For example, I am increasing the input voltage to V max, it is equal to 16 volts or R is 30 ohms. That time I max, what is I maximum? It is 16 minus 10 by 30. We are getting 200 milliampere. I is reaching its maximum value. Okay, that time still RL is minimum only. So that IL is maximum. What is IL maximum here? 85 milliampere, right? It is 85 milliampere. So IL maximum. it still remains at 85 milliamperes. Okay. That time what is IZ? IZ is equal to 200 minus 85. Okay. That is 115 milliampere. As V input is increasing from 13 to 16 volts, I is increasing, accordingly IZ is also increasing. Okay, IZ has reached up to 115 milliampere. I can't call this as IZM because still there is a scope for RL to increase. If RL increases, IZ will definitely increase. Then what we did, keeping input at its maximum value, we started raising the value of RL to RL maximum, so that IL is decreasing, then IZ is further increasing. And to what level IZ is going? It is going up to a maximum of 190 milliampere. Because IL, as you are increasing RL, IL is decreasing and it is coming down up to 10 milliampere. So what might be the value of RL maximum? It is a 10 by 10 or 10,000 by 10, 1 kilo ohm. Okay, RL maximum is 1K and RL minimum, I have not calculated it, we can do that, or 10,000 by 85. You can do it, notice there in it. 117. 117.6 ohms. So this is RL minimum, we can see. So it is starting with input minimum of 13 volts and RL minimum of 117.6 ohms. Right, we are starting that circuit operation is starting. Next, we are increasing input. Yes, I will increase, and you are increasing the input up to its maximum value like this, so that I is reaching its maximum value, but IZ is not its maximum value because RL is still at its minimum value. Further, you are increasing RL to its maximum value of 1K. That time, right, as IL is decreasing, IZ will go up to 190 ohms because IL maximum, here we have got 200 milli, it is also 200 milli. It remains the same. IL maximum cannot change. Sorry, I maximum cannot change. But as your RL is increasing, definitely IZ will increase and it reaches a maximum of 190 milliampere. That's it. This is the idea. So whenever you vary the input between 13 volts to 16 volts and RL between 117.6 ohms and 1 kilo ohm, the Zener diode will adjust. It is not mandatory for I to increase continuously. I is independent of RL. I depends only on input voltage, and IL varies depending upon the value of RL, and IL never depends upon your input. Okay, whenever you are changing the input from 13 to 16 volts, 13 volts to 16 volts, that time I is only changing but not your IL. Okay, input is changing from 13 to 16 volts, but IL is, as RL is fixed, IL is fixed. Later, once you start varying RL, IL is changing, but that is not influencing your I. I remains there only. Okay. Meanwhile, IZ is only changing. The Zener diode is adjusting its currents. Okay. So you may vary the input, you may vary RL. Depending upon input, I only can change. Depending on RL, only RL can change. But whether you change input or RL, IZ will change. That is the final conclusion. Okay. Very simple analysis. During this process, if they give in the data, well and good. If they do not give, we take IZ minimum is 0 and RL maximum is infinity if they do not give. See the next question. In the circuit shown, a 5 volts Zener diode is used to regulate voltage across RO, means output resistance RO. Okay. The input is a unregulated DC voltage with a minimum value of 6 volts and a maximum of 8 volts. Okay, input range is given. The value of RS is equal to series resistance is 6 ohms. The Zener diode has a maximum rated power dissipation of 2.5 watts, means IZM is given indirectly. Assume that the Zener diode to be ideal, the minimum value of RO is, what is RO minimum? Okay, so what is IZ minimum? They have not given. Now I can assume IZ minimum is equal to 0. Okay, so assume IZ minimum is equal to 0 or knee current. Okay, done. So IZ minimum is known, and IZ maximum is also known to us. Okay, but we do not know RO maximum. Now how to find RS from the given data? As I current is minimum, then okay, we should find the value of RS is given. No? So as input is minimum and IZ minimum is also known, right? I can use, right, let me write the circuit otherwise. That gives much better way of understanding. So here input is minimum, RS is 6 ohms and the corresponding current high here is minimum, right? And it is RO minimum means IL maximum. And what about IZ minimum? It is 0. Is it not so? And what about VZ? It is 6 volts. Sorry, 5 volts. And input minimum is 6 volts. Over. Everything is done. Okay, so what is I minimum, friends? It is 6 minus 5. V input minus VZ by R. It is 1 by 6 amperes. I minimum. Then I can write RO minimum is equal to VZ by IL maximum, that is VZ by I minimum minus IZ minimum. Is it not so? Okay, that's it. This is how we can do the calculations. So VZ, it is 5 minus I minimum 1 by 6 minus the knee current. They have not given, no? So what we take? It is 0. Automatically it is equal to 30 ohms. Okay, that's it. RS is given, Zener diode power rating of the Zener diode is given, and the assume Zener diode is ideal. That's it. And if they ask us to find RO maximum, then what do? Okay, we have to take input maximum, and from power dissipation rating of the Zener diode, we can find IZ maximum. From that, I maximum minus IZ maximum gives us IL minimum. From IL minimum, we can find RO maximum. That's the idea, right? Anyway, out of curiosity, if you want, you can do that, but here it is enough. Just I write the steps. So very, very simple thing actually. RL maximum, input is maximum, RS is 6 ohms. Here I is maximum, IZM, IL minimum. So I max is equal to V max is equal to 8 volts and VZ is 5. So 8 minus 5 by 6, 3 by 6, 1 by 2 amperes. And power rating is given. or IZM I can write here. It is just out of curiosity only. We are doing PZ rated by VZ. It is equal to, what is the rated power, friends? 2.5 watts by VZ is 5. So 0.5, 1 by 2 amperes. Oh, IZ maximum is equal to I maximum, means what is IL minimum, friends? IL minimum is equal to I max minus IZM. It is simply 0. IL minimum is 0, means what is RL maximum? It is infinity. It's a coincidence. It need not be, but in this problem it is a coincidence. RL maximum is found to be infinity and RL minimum is 30 ohms. Okay, that's it. Okay, this is how we can. Right? Sometimes we can do some post-mortem, right? At the time of learning only you can do all such things. Okay, but it is a coincidence. It is not mandatory that IZ minimum is 0 means RL maximum is infinite. Right? It is a coincidence. Next, see this question. A Zener diode in the regulator circuit shown in figure has a Zener voltage of 5.8 volts and a knee current of 0.5 milliampere. The maximum load current drawn from the circuit entering the proper functioning over the input voltage range is, okay, the range of input is given, RL range is not given. Okay, so the maximum load current drawn they are asking. So there is a load resistor, no doubt about it, which is a variable. Okay, they have not shown, they mentioned load. And IL is maximum if and only if RL is, IL is maximum means RL minimum. Okay, so RL is minimum and input is minimum, that time IZ is minimum. The knee current is given. So what is the circuit? Immediately the circuit that should come in your mind should be like this. Input is minimum. RL is minimum. That time it is the knee current. As input is minimum, it is I minimum. As RL is minimum, IL is maximum. So they are asking maximum load current drawn. How much? Input minimum I should take here. It is 20 volts and R is 1K and VZ is 5.8 volt. Okay. So what about I minimum? It is 20 minus 5.8 by 1K. It is 14.2. It is also appearing here. Don't take that as your answer. And IL maximum is equal to I minimum minus the knee current. It is 4.2 minus the knee current, it is given as 0.5 milliampere. So it is 13.7 milliampere. Option B is correct. So we should be very careful. It's a simple question, but I had a lot of debates on this question. So no difficulty in it at all once you understand the concept properly. Okay. Next. Yes. See this. The range of series resistance. Okay. So far, what we have seen, I started with the very basic regulator circuit and I did some problems on this. Fixed values. Input is fixed, R is fixed, RL is fixed. We did some problems in the previous lecture. In the current lecture, I varied the input keeping RL constant, did, and I kept input constant and I varied RL, we did some analysis. Now, next I varied both and did it. Now, coming to the range of series resistance. Right? Is it necessary to vary it, or is there any possibility to vary this also along with the two, input and RL? Yes, it is. Okay, how to do this? See this problem. The very first question. Before going to the analysis, I'm starting here problem. Every time I did analysis, next I go to the problems. But here there is small twist. That's why I'm doing it so. Why? To find the range of R. For that sake only. See, in the circuit shown below, the Zener diode is ideal with a Zener voltage of 6 volts. The input voltage in this case. Okay, its breakdown voltage is 6 volts. Fine. And the input is greater than its breakdown voltage. The moment you see, you feel like the output should be equal to 6 volts. That's what we take by default. But is it right so? Such a simple problem they asked. Okay. It's a regulator circuit. Everything is looking fine. So just see this question. If that is the case, assume the Zener diode is under breakdown. It looks like so. So based on that, I am writing it. So assume Zener diode is under breakdown. If that is the case, right, this is how we can see the things. Ten volts, 1 kilo ohm, it should be 6 volts, 1K, and IL. V output is equal to 6 volts. So what about IL, friends? Vz by RL, it is 6 milliampere. Okay. And what about I? I is equal to V in minus Vz by R. 10 minus 6 by 1K, 4 milliampere. Is it possible to get 6 milliampere from 4 milliampere? Meaningless. If that is the case, what about Iz? You are getting Iz is equal to I minus IL, which is negative, not possible at all. If that is the case, what do we get for Iz? See, if the Zener diode is under breakdown, then the current is flowing from cathode to anode. Our cathode is at a higher potential compared to anode. Higher potential to lower potential, the current is coming negative. Is it possible? Meaningless. Absolutely wrong. What is Iz minimum under ideal case? Iz minimum is 0, right? Cathode to anode current, if the Zener diode is under breakdown, the current from cathode to anode should be greater than 0. Ideal case, it is minimum is 0, but it cannot be negative. It is Iz, cathode to anode current is negative, means anode to cathode current is positive. Anode to cathode current is positive means the Zener diode should be forward biased. With this power supply, is it possible for Zener diode to be forward biased? Meaningless. The cathode is connected to positive terminal and anode is connected to negative terminal. It should be reverse biased. With reverse bias, it looks like it is under breakdown because input is greater than its breakdown voltage. But the thing is, the value of R here is so chosen that the current through the Zener diode is coming negative. Current through the Zener diode cannot be negative, right? If it is under breakdown. The current from cathode to anode is looking like negative. It is not possible. Either it can be 0 or it should be positive if it undergoes breakdown. Means the Zener diode is not under breakdown. Is it not so? Okay. In the same problem, right? So Zener diode, current through the Zener diode cannot be negative. It is not possible. As it is not possible, Iz should be 0. Right? Iz cannot be positive. It can be either 0. Means the Zener diode may be right acting as open circuit only. Iz is 0 means I is equal to IL. If that is the case, if Iz is 0, then what I can write here in the given circuit? if Iz is 0, 10 volts, 1 kilo ohm, 1 kilo ohm, and I and IL. So what is V output? And here I is equal to IL. Okay, so what is V output? It is equal to 10 by 1 kilo ohm plus 1 kilo ohm into 1 kilo ohm, 5 volts, which is less than Vz. This is what we can observe. So what is this twist? See, the value of R is so chosen that even though input is greater than the breakdown voltage, the Zener diode is unable to undergo breakdown. That is the interesting part here. Okay. See, in the same problem, I am taking R is equal to some 0.5K. Okay. Suppose my circuit is like this. Same 10 volts, and it is Vz is equal to 6 volts. Now you see this. See, even when I started the diode applications, I mentioned by changing the resistor circuits, diode models with respect to DC biasing circuits, DC biasing circuits we have seen. Just by changing the resistor value, it looks like the diode is in conduction, but it may not. Or it looks like it's not conducting, or it may conduct. These are all the things. All right. There, what we did, once it is forward biased, current through the diode should be positive. If you get negative, definitely our assumption might be wrong. But default, it looks like diode is on, more maximum cases. Depending upon the polarities of the supply and all, it looks like it may be in conduction. But once you calculate the current through the diode, then we understand that diode is not conducting. Such problems we did, multiple problems we did, so many. Okay, now you take this current I, Iz, IL. So assume Zener diode is under breakdown. If that is the case, what is Iz? Vz by RL, it is 6 milliampere. And what about I? It is V in minus Vz by R. It is 10 minus 6 by 0.5K. It is 8 milliampere. No doubt it is greater than IL. And hence Iz is equal to I minus IL. It is 2 milliampere. Everything is perfect. Okay, so far the problems what we did, if you consider the value of R is so chosen that for the given range of input or for the given range of RL, Iz is within the range Iz minimum to Iz maximum. Under ideal conditions, Iz minimum was found taken to be 0. That's it. And Iz cannot be negative. Here, in this problem, the value of R is so chosen that even for this particular value of R, even though the input is greater than Vz, it is not under breakdown. So definitely R is also influencing our circuit. That's why we need to look at the range of series resistance as well. This is why I did this problem first before going to the analysis. Okay. So here I am taking various cases. Like V input is varied, then how to find the range of R? And if I vary RL, how to find the range of R? And if I vary both input and RL, how to find the range of R? Like that, case 1, case 2, case 3. Okay. And one more interesting thing I can take here is from this problem what we understand is, see this, first I started with RL is equal to R is equal to 1K. For R is equal to 1K, Iz is negative. So what I did, I have not increased the value of RL. If I increase the value of R further, I value will further decrease. What I did, first from the given value of R, I calculated I. Anyway, RL is fixed, IL is fixed. So I value is looking like less than IL. That's why we are getting Iz negative. So for I Z to be positive, what we should see? I should be greater than IL. For I to be greater than IL, what I did? I reduced the value of R. Okay. So there is an upper limit for R such that current through the Zener diode should not fall below its knee current. Is it not so? There is a maximum value of R. Or I can say here, okay, see this. R is equal to Vn minus Vz by I. So here R is inversely proportional to I, no doubt about it. Or I can write I and R. If I increase R, then I will decrease. If I decreases, then definitely, even though input is constant, as I is decreasing, Iz will decrease. Here this may be constant. See the concept here. Okay. If I decrease, if R increases, Iz will decrease. No doubt about it. Inverse relation. Okay, R decreases, R increases, I will decrease. If I decreases, Iz will decrease. Okay, so means we should see that even for the maximum value of R, current through the Zener diode should not fall below its knee current. Understand? Right? Again, if you reduce R, then I will increase. If I increases, Iz will increase. So even for the minimum value of R, I should not go beyond a certain value such that Iz should not exceed its Izm. This is the basic idea. Okay. I is anyway proportional, Iz is anyway proportional to I, no doubt about it. But there is an inverse relation between I and R. Is it not so? Okay. So what we can understand is R is inversely proportional to I. Right. Anyway, Iz is inversely proportional to R. And Iz is proportional to I. And I is inversely proportional to R. No doubt about it. Keeping these points in mind, I can take the first point like, okay, I will come to this case 1. First, what I can write is R is equal to Vn minus Vz by I. So R is proportional to 1 by I. So R minimum comes from I maximum and R maximum comes from I minimum. This is what you need to understand. So what I can write is R is equal to Vn minus Vz by I. I am writing I is minimum. R comes from R max comes from I minimum. R max comes from I minimum means I is minimum means input also should be minimum. So very, very simple thing. And I minimum can be written as, what is I minimum? It is the knee current plus IL. Is it not so? Okay. Next, what about R minimum? R minimum comes from I maximum. I is maximum means input should be maximum minus Vz and Vmax minus Vz by Izm plus IL. That's it. Those are the statements. That's how from V minimum I can find R maximum. From V minimum we can find R maximum, and from V maximum we can write R minimum. Please do observe this. We'll see that. Okay. So my concern here is, right, I will write it in much better way. I, Iz, IL. So we know R is equal to V in minus Vz by I. R is proportional to 1 by I. Right? It is an inverse relation. So R max comes from I minimum and R minimum comes from I maximum. So I can write here the circuit. RL. Here IL is fixed. So as if input is minimum, the corresponding I is minimum. I is minimum means the current through the Zener diode is also minimum. As I is minimum, R is maximum. So I can write here R max is equal to V minimum minus Vz by I minimum, and V minimum minus Vz by I minimum is the knee current plus IL, where IL is equal to Vz by RL. Okay, so very simple thing. And the next case, from means here R is proportional to 1 by input. We can write because I is always proportional to input. I is proportional to input. No doubt about it. So as input is maximum, definitely R should be minimum. As input is maximum, I can write I maximum, and Iz is always proportional to input. IL. So R minimum is equal to Vmax minus Vz by I maximum. It is Vmax minus Vz by Izm plus IL. That's it. So very simple thing. First case. I don't know if it is visible to the students or not. Okay. So this is how we can see this first case. And see this question. It is a question asked in previous papers only. Oh, not previous papers. I framed this question for better understanding. Nothing else. Right. We'll see the previous questions as well after this. A 5 volts Zener diode with a current rating like this 10 to 99 milliamperes. Zener diode is used as a voltage regulator shown below. If V input varies from 10 to 15 volts, find the range of R. That's series resistance. How do we do it? Okay. So as usual, I'm taking here input minimum. From V input minimum, I can see R maximum, I minimum, it is the knee current which is equal to 10 milliampere. RL is equal to 1K. If that is the case, IL is equal to 5 volts, no? So it is 5 milliampere. Okay. So V minimum, it is 10 volts. So what about R maximum? It is V input minus Vz by I minimum. Okay. V minimum minus Vz by Iz minimum plus IL. 10 minus 5 by, it is 10 milliampere plus 5 milliampere. How much we are getting? 5 by 15, 1 by 3K, 1000 by 3. It is 333.33 ohms. Okay. That's maximum. Next. Okay. Next, R minimum. V input is maximum, R minimum, I maximum, IZM as it is 5 volts. So R minimum is equal to Vmax minus Vz by IZM plus IL. Vmax is equal to 10 to 15, no? Okay, 15 minus 5 by IZM, it's 99, no? 99 milliampere plus 5 value. 10 by 104 into 1000. 10,000 by 104. 96.15. Yes. So you can vary your R from 96.15 to 333.33. Right? You are varying input and you are varying R. Still, you can see the constant output voltage Vz across RL. Okay. So R max comes from V input minimum. Please observe this. Okay. And sometimes they may not give IZ minimum. If they do not give IZ minimum, what do you take? IZ minimum is equal to 0. Then you can calculate R max is equal to V minimum minus Vz by IL. IL and I will be same, of course. Okay. In this case. Fine. Right. Next case is, anyway, when input is maximum, it is around 15 volts. That time, anyway, I maximum, IZ is maximum, and R minimum. How much you are getting? Instead of 333, right, it is starting with a maximum of 333. It is coming down to a minimum of 96.15. Right. Okay. Next, I'm taking the next case like this one. Keeping input constant and vary the load resistor. Okay. Earlier, when RL is fixed, IL was fixed. Now input is fixed, this I is fixed. And we know IZ is always proportional to RL. Is it not so? Okay. Right. So it looks like I is fixed, but we are finding the range of R. Once R is varying, definitely I has to vary here. It looks like I is constant. When is it possible? If V input is constant and R is constant, that time I is constant. But I would like to find the range of R with varying load resistor and keeping V input constant. That's my concern. Okay. Then as R is varying, I will also vary. No doubt about it. Okay. Then what we can do, when RL is minimum, IL is maximum, IZ is minimum. Okay. And IZ is minimum, and hence we can take the corresponding I as I minimum. You can't take that I as I maximum. Okay. So see this. RL is minimum. Definitely IZ should be minimum. IZ is always proportional to R, and hence it is knee current. It is V input. As current is IZ is minimum, I should write I minimum only. I cannot write I maximum and all. Okay, this is IL maximum because RL is minimum. Okay, as IL is maximum, I cannot take I is equal to I maximum, right? I and IZ, if you take it, IZ is minimum means I should be minimum. As I is minimum, R is maximum. 100%. It is a valid statement. Okay. That statement will never change. You are writing I minimum means IZ should be minimum and RL should be minimum. Okay. 100% we should take that only. Okay. Then what about your R maximum from this? You cannot take a unnecessary other probabilities. R max is equal to, here V in is constant only, and Vz by R is maximum means I should be. What is I minimum? It is V in minus Vz by current through the Zener diode should be minimum, and here as R is variable, I right, definitely IL should be maximum. IL maximum is equal to Vz by RL minimum. Okay. I minimum you cannot write in terms of Iz maximum. And you cannot use that combination Iz maximum and IL maximum. You can't even write Iz maximum and IL minimum. Here I is not constant because R is variable. If R is not variable, then definitely I might be constant. Okay. Take the second case. Input is constant only. RL, right? And input is constant, and I'm taking Iz is maximum. Iz is maximum means I should be maximum. I is maximum means R should be minimum. Iz is maximum if and only if RL is maximum. So IL should be minimum. That's it. Then what about R minimum? It is equal to V in is constant, Vz is constant, but I should be maximum. It is V in minus Vz by Izm plus IL minimum, where IL minimum is equal to Vz by RL maximum. That's it. No doubt about it. Okay. So, see the next question based on this. See this question. The same Zener diode. I'm not changing my Zener diode. It's a 5 volts Zener diode with Iz minimum of 10 milliampere, Iz maximum of 9 milliampere. Now I'm varying RL. Okay. I want to find the range of RL. Yes. Okay. Series resistance R if the load resistor is varying from 0.5 to 5 kilo ohms. Okay. I took some intermediate value in the previous problem, that is RL is equal to 1K. Let it be. So here I am coming to the first case. Iz is minimum. That is possible if and only if RL is minimum. It is 0.5K and hence IL is maximum. Its value is Vz is 5 by 0.5K. It is 10 milliampere. IL maximum. What about the knee current? It is 10 milliampere and the corresponding I is minimum and R is maximum. So R max is equal to 10 minus 5 by I knee. It is 10 milliampere plus 10 milliampere. It is 5 by 20, 1 by 4, 1 by 4,000 by 4. It is 250 ohms. Okay. Same Zener diode only, but here RL value is decreasing. RL is decreasing means definitely, right, the corresponding value of RL is decreasing, IL is increasing means I minimum will automatically change. Okay. Here you can see the influence of RL on I. That's possible if and only if R is variable. If R is not changing, I depends only on V input. Now I depends on RL, input is constant. RL varies, IL will vary, and IZ can't fall below knee current. Obviously, I is changing. Okay, R maximum. In earlier case, we got 333 ohms. Now it is 250 ohms. Okay. Next. I can directly write use the formula and write it, but once you see these things, students will not forget them. That's my concern. It is 10 volts. RL is maximum, means IL is minimum. 5 volt. 5 by 5k, it is 1 milliampere. IL minimum is equal to 1. As RL is maximum, I can't take IZ to be minimum. IZ is maximum. Means I is maximum and R should be minimum. So R minimum is equal to 10 minus 5 by I maximum. IZM, how much it is? 99 milliampere, and it is 100 milli. 99 milli plus, sorry, 1 milli. It is 100. So it is 50 ohms. Okay. Why to write? So R minimum is 50 ohms. In the previous problem, if you take so, R minimum, how much we got? It is 116 point something. I do not remember the value. 96. 96.15 R minimum. Now, what is R minimum? In this particular case, it is found to be 50 ohms. Okay. Next, I'm taking the next case. Like both input and RL are varying. You can just understand, just like that you can do this. Both input and R. So, what is the range of this R? I want to see. Just like that you can write. So, when input and RL both are minimum, that time IZ is minimum. Okay. So, input is minimum, IZ is minimum. Anyway, both input and RL are minimum, right? That time IZ is minimum. We know that. So, as RL is minimum, IL is maximum. So, I take this as I minimum, R maximum. This point you need to understand. Just like that you can write the remaining things. Then, what is R max, friends? It is V minimum minus Vz by I minimum. Actually, Vin minus Vz by I. Input is minimum and hence I is minimum. Okay, so V minimum minus Vz by I minimum means it is a knee current plus IL maximum over. Input is maximum, RL is maximum. That time IZ is maximum. As input is maximum, it is I max. As I is maximum, R is minimum. See this. As RL is maximum, IL is minimum. There is nothing to mug up. V output is equal to Vz. It is Vz by RL max. So I can write here our IL maximum is Vz by RL minimum. Anyway, we need not worry about it. So R minimum is equal to V max minus Vz by I max. That is V max minus Vz by IZM plus IL minimum. That's it. And during this process, if they give IZ minimum, well and good. If they do not give, we take IZ minimum 0. So many times I told. If RL minimum, maximum, if they give, well and good. If they do not give, we take RL maximum is equal to infinite. That is true. That's it. Right. So let us have a look at a problem on this. I'm taking the same Zener diode. That is a Zener diode with a breakdown voltage of 5 volts, and the current range is from 10 to 99 milliamperes. If V input is varying from 10 to 15 and RL is varying from 0.5 to 5K, same data, first problem and second problem I am combining, then find the range of series resistance R. Okay, so this. I minimum, it is the knee current, IL maximum. So IL max is equal to VZ by RL minimum. VZ is 5 volts, 5 by RL is varying from 0.5K, it is 10 milliampere. Okay, then R max is equal to, what is V minimum? It is 10 volts. 10 minus 5 by the knee current, it is 10 milliampere, and 10 plus 10, 10 milliampere plus 10 milliampere. How much do you get? 5 by 20, 1 by 4 means 250 ohms. Okay, same value we are getting because we did it with 10 volts. In that problem I took input as 10 volts. That's why we are getting. Okay. Next, second case is V input is maximum. It is IZM. This is maximum. R should be minimum. We know that it is 15 volts, 5 volts breakdown voltage. IZM is 99 milliampere. IL maximum, it is VZ 5 by RL maximum, I think 5K. 1 milliampere. So what about R minimum? 15 minus 5 by 99 milliampere plus 1 milliampere. It is a 10 by 100. So 10 by 0.1, 100 ohms. Okay. 99 and 1 milli. 5K. Oh, sorry. Yes, 15 minus 10, 10 by 100 ohms. That's it. This is how we can do this problem. Very simple. Okay, R minimum is equal to 100, R maximum is equal to 250. Absolutely we are getting. You will not get any conflict. You will not get R maximum less than R minimum, meaningless. See, the very first statements I gave, those equations keep on repeating. There is nothing to mug up. There won't be any confusion at all. Those are all universal statements. Okay, so IZ is minimum if and only if input is minimum. If input alone is present, or IZ is proportional to RL, RL minimum, right? IZ is minimum if and only if RL is minimum, if input is constant. Or both vary also, IZ is minimum if and only if input and RL are minimum. That's it. Based on that, anyway, R is inversely proportional to I. I is maximum, R is minimum. I is minimum, R is maximum. That's it. The remaining things will be automatically taken care of. Now, let us see some more problems asked in previous GATE papers. GATE 2002. Okay. A Zener diode regulator in figure is to be designed to meet the specifications. IL is equal to 10 milliampere, V output is equal to 10 volts, and input varies between 30 to 50 volts. The Zener diode has VZ of 10 volts and the knee current of 1 milliampere. For satisfactory operation, what should be the value of R? Indirectly, they are asking the range of R. Okay, and in this, RL is fixed, IL is fixed. Okay, so input is varying between 30 to 50. And IZ is minimum is given. IZ minimum is given means I should be minimum. I is minimum, that's possible with input minimum. That point you should understand. If IZ maximum is given, then I is maximum, the corresponding input is maximum. Okay, so what should we write here? If I take this circuit, we did this one already, the first case only. Okay, input should be 30 volts, and this is what we get here is, anyway, IZ minimum is given, knee current, and hence I is minimum. I is minimum means you will get R maximum from input minimum. RL is anyway not given, nothing to worry about it. Its output is 10 volts and it is 10 milliampere. So it is like 1K. They have not given, but it is 1K. 10 volts by 10 milli, it will be 1K. They are not given, but you can. Okay, nothing to worry about it. So what about our R maximum? The maximum allowable R, it is 30 minus 10 by knee current. It is 1 milliampere and it is 10. So 1 milli plus 10 milli. It is 20 by 11 kilo ohm. It is 1818 ohms. So R should be less than 18, less than or equal to. If R exceeds this value, current through the Zener diode falls below its knee current and Zener diode comes out of breakdown. Means it is no more a regulator. So R can be a maximum of 1818. Means it looks like first option is matching. Okay, R greater than 4000, is it possible? Not at all. R cannot be greater than 1800. That's it. Here it is looking like greater, not possible. This is also looking greater. This is also looking greater than 1818. So definitely option A is correct. Okay, if I maximum is given, IZ maximum is given, then we can find R minimum, but not necessary, not required here. If you look at the options, okay, you are calculating directly R maximum. That's it. See how simple you can do this problem. Next, at 12 volts, 5 to 50 milliamperes, Zener diode is used as voltage regulator. Load current varies from 5 to 40 milliampere. Find the range of series resistance. So what is there in it? Okay. Load current is varying, means second case. Right? Keeping input constant, RL is varying. Then how to find RS? Okay. So just like that we can do. RL is minimum. IL is maximum. IZ is minimum. Anyway, input is constant at 22 volts. As IZ is minimum, the current through the Zener diode is minimum, then RS is maximum. What is the knee current, friends? It is 5 milliampere and IL maximum. Load current varies from 5 to 40 milliampere. So RS maximum is equal to 22 minus, so 12 volts. 12 by 5 milli plus 40 milli. It is a 10 by 45 into 10 cube. 10 by 45, 5 to 2 by 9 by 2. Sorry, 2 by 9. It comes around 222, no? 222 ohms. Place issue. Second case, 22. RL is maximum, IL is minimum. IL minimum, it is 5 milliampere. This is IZM, means I maximum, and RS is minimum. IZM how much? It's 50 milliamp. So RS minimum, it is equal to 22 minus 12 by 50 plus 5. 10 by 55 into 1000. Okay. $181.8. Ohms. So what is the range? 181 to 222. Option A is correct. Is there any difficulty in this? See how simple the questions in GATE are. Actually, regulators is a very, very simple topic, but people unnecessarily argue on this. There is nothing to argue. Okay, look at this question. We can see all these combinations. Like the first stage is rectifier, and the next one is filter, and next one is voltage regulator. Is it not so? All are included here. Okay, a sinusoidal source of figure shown in figure has RMS value of 20 by root 2. VRMS is given. So what implies what is VM? It is VRMS multiplied with root 2, that is 20 volts. VM is known. And what about the input to the capacitor? Okay, so considering all possible values of RL, R suffix L, it is considering all possible values of RL, the minimum value of RS in ohms to avoid burnout of the Zener diode. Okay, this is a question. Electrical paper 2014. All possible values of RL means what you can take for RL maximum? Infinite. RL is maximum, and for it is a regulator, right? For the regulator, let me take this is VO1, right? And it is V output. VO1 maximum is equal to VM. It is possible. When input is maximum, RL is maximum, that time IZ is maximum. And the corresponding this current I is also maximum. I can take that case. Is it not so? When I is maximum, I will be maximum if and only if input is maximum. And RL is varying, we should take RL maximum also. RL should be equal to RL maximum whose value is infinity. Because all possible values they mentioned. So that IL minimum will be equal to 0. Input is maximum, RL is maximum, IZ is maximum. And hence I is maximum. I is maximum means RS is minimum. The minimum value of RS is asked. Nothing else in this problem. And a capacitive filter output. Under ideal conditions, what is V output? Maximum capacitive filter output. It is equal to Vm, peak amplitude of the input voltage. That's it. So V capacitor maximum is equal to Vm. It is equal to 20 volts. Now I'm writing RS minimum. RS is minimum means I should be equal to maximum. It is possible with input maximum and the Zener diode. Here I can write RL is maximum and assume RL maximum is equal to infinite. Is infinity means IL minimum is equal to 0. IL minimum is equal to 0. If that is the case, IZM is equal to I maximum. And how to find IZM? Here its a rating is given 1/4 watts. So let me take IZM is equal to PZ rated by VZ. It is 1/4/5. It is 1/20 amperes. Okay. Then RS minimum is equal to Vmax minus Vz by IZM plus IL minimum. Vmax it is 20 minus Vz, I think 5 by 1/20. It is equal to 300 ohms. That's it. Okay, I hope you all understand this question. Okay, it is Vrms secondary. So Vm is equal to Rms multiplied with √2, that is 20 volts. That's it. That is the maximum value of possible input to our regulator circuit. Input is maximum, RL maximum we can take infinity. So IL minimum will be 0. When input and RL are maximum, I is maximum, IZ is maximum, I is maximum, RS is minimum. That's it. This is how we can do this, right? And remaining problems I will discuss in the next section.